Hey everybody!
Hey everybody! Welcome to the third video of this Jitter course. So in this video we are going to see how to create images from scratch. So not using a pre-existing material, but filling some pixels procedurally. So in the last videos we saw the object jit.matrix. We saw how this object is used by Max to store multidimensional data. So what does it mean, multidimensional? It means basically that we can store a multidimensional array inside a JIT matrix. For example, an image. Let's take, for example, a video here. Use JIT window to visualize it. Why multidimensional? Because we have a x dimension and we have an y dimension. In case we have only a one-dimensional matrix, we cannot actually display an image. I mean, we can display an image, but this will be just a one-dimensional image. So let's see, for example, how this video will look in a one-dimensional image. So let's first give the arguments to the JIT matrix object. If you remember, the JIT matrix object takes a bunch of arguments. The first one is the name, but this is optional, so we can just skip it and just go directly to the number of planes. So since we saw that every video and image in Max is by default represented in a JIT matrix with the 4 planes, so we give it the number 4, which represents the planes that our matrix will contain. These planes will be alpha, red, green and blue. Then we give it a data type, which by default is char. And let's give it then one dimension, for example 320, but only one dimension. So this now is a one-dimensional matrix. Let's attach this video here. Let's get a JIT window here to see what we get on the output, and let's play the video. So as you can see, this is now a one-dimensional matrix, which basically takes only the last row of pixels here on the top and displays only this row also on the y dimension of this matrix. So the same color that is here gets displayed on the whole matrix. Okay, so this is a one-dimensional matrix. Now let's take a look at a new object. Let's set the dimensions to 10 here, and let's take a look at a new object called jitnoise. Now the jitnoise object generates a bunch of random numbers. It's a bit like the random object. We generate a number between 0 and this number that you write here, -1, so in this case from 0 to 9. And the jitnoise fills a matrix with random numbers in the range from 0 to the maximum number allowed by the data type that we give it. And the jitnoise takes the same arguments as a JIT matrix. So for example, if we say let's create a jitnoise with one plane, so only one single layer of this matrix will be filled with data, then the data type, so for example char, and then some dimensions. So this will give us a one-dimensional matrix, because we have only one dimension here. As you can see, we don't have 2 dimensions, we have only one, with one plane of data type char. So this will give us random numbers inside a matrix that go from 0 to 255. And let's display these random numbers using a JIT window. Since this is only going to be a one-dimensional, we can just make the P window kind of flat. And let's take a look at these numbers by giving a bang to the JIT noise. Okay, so as you can see, it filled the JIT window with random numbers and from 0 to 255. Now, as we saw last time, the JIT window, when it receives a one-plane matrix, it will represent it as a grayscale. We can also attach the JIT cell block to see those numbers that we got. And as you can see, these are all numbers in the range 0 to 255. These are 10 numbers, because this is a one-dimensional matrix with 10 cells inside. So this is a one-dimensional matrix because we have only one dimensions, one plane, type char, and it gives us this grayscale. If we would have 100 cells, this will give us 100 random numbers between 0 and 255. So this is very cool. We can use the jit noise for a bunch of different things. It gives us access to random numbers, which is always a very good thing to have when we work with procedural graphics. But jit noise can generate not only one layer of random numbers, but it can generate as many layers as we want, going up to 32. So for example, we can generate random colors by giving it 3 planes. So these will be now interpreted as red, green and blue. So now this jit noise will generate some random numbers in the range 0 to 255 that will be interpreted by GP window as random colors. So as you can see, we have those random colors here inside the GP window. We can also attach the jit noise to the jit matrix and store those random values inside this jit matrix. Let's actually go back to a dimension to 10 pixels per matrix. By the way, let's actually write this down. When we're talking about images, a cell in a matrix is equal to a pixel. So we can write pixels equal cells, because there is actually no distinction. A cell is the container inside the jit matrix in which the data is stored. So basically this we can see it in the jit cell block as this rectangle here. This will be a cell of the matrix. But when talking about images and videos, so a cell becomes actually a single pixel, because it stores the value that form the color of the pixels. So let's actually move this a bit on the right. And let's attach a new jit cell block here. Let's bang. Oh, and by the way, this has still this matrix I left with 4 channels. I forgot to change this to 3, but as you can see, it makes actually no difference, because the first channel, the alpha channel, gets just filled with one of those channels from the jit noise. So one of those channels, I think the first channel gets copied and fills also the alpha channel. So practically it made not it had not effect, as you can see. Oh, let me write that this is actually called jit window. We can actually also change the size of the jit cell block displaying from here. So default column width, we can change this, for example, to 30. Okay. Maybe we can reduce also the font size to 7. And this actually to 15. No, let's say 20. Okay. So in this case, we basically created an image from scratch. These colors didn't exist before, and we created them using jit noise and storing them inside a jit matrix. Every time we bang the jit noise, we get different colors, which are completely unrelated between them. We can also display the other planes. By default, jit cell block, remember, display just the first plane, which is plane 0. But we can also take a look at the other planes by giving the message plane followed by the index of the plane. So as we saw last time, the first plane has index 0. So this will be the red plane when we're talking about images. And the plane 1 will be the green color. Plane 2 will be the blue color. So this is, in this case, this is how the planes are organized. Now, if we want to have a two-dimensional matrix, we have to give it another number here, which is our second dimension. Now, if we fill the matrix with random numbers, now we can see that this is actually a two-dimensional grid of random numbers. So 100 random numbers on 3 different planes, from 0 to 255. Okay? So we are basically creating an image from scratch, just filled with random colors. Now in this case, we are displaying these random numbers as colors, but we can also use them. We will see how to use them in the future for different purposes than just displaying a random color. Now, if we want to to clear this matrix, to get it back to black, we can send it the message clear to jit.matrix. But we also need to send a bang then to the jit.matrix to send out its matrix, because when we just send clear, it doesn't output anything. It needs a bang to actually send out the new cleared matrix. So we can actually just write clear, then comma, and bang. So this will mean that the message clear goes out, and then the message bang goes out as well. So jitnoise, we fill the matrix with random numbers between 0 to 255, and if we want to clear and output the new matrix, we send the message clear followed by a bang. That's it for the jitnoise for the moment. Let's actually copy this matrix and the GP window and see another way in which we can create basically some colors from scratch. We can set the value of the individual cells with numbers of our choice. So for example, if we create a list with written set cell to D, then 2 numbers for the coordinates, so 2 integers, and then 3 other integers for the color. So this message, since it's a set cell 2D, it knows that it will have 2 numbers for the 2-dimensional coordinates, so x and y, and then 3 numbers for the color, so red, green, and blue. So this is what this integer I that we write here stands for. So this helps us to introduce the concept of coordinates inside a matrix. Now let's go back here to the cell block object. You can see that this is a 2-dimensional grid with some numbers inside. Now let's say that I want to know the coordinates of this cell here. Now what I have to do is just to count how many cells I am on the x dimension and how many cells I am on the y dimension, but starting from 0. So the cells, as the plane, they start the index from 0. So for example, this will be cell 0, this will be cell 1, this will be cell 2, this will be cell 3, this will be cell 4. And the same goes for the vertical dimension, so for the y dimension. 1, 2, 3, and 4. So if I want to know the coordinates of these cells here, where the 71 is, this will have coordinates 3, so x equal 3, and the y will be equal to 2. So this cell has coordinates 3 and 2. Now, if we go back here, let's say that we want to make this cell, the cell at 3 and 2, we want to make this cell red. So what I have to do is first I have to create some integer numbers for the coordinates and some integer numbers for the colors. So I will attach here to the second element of the list, this will be the third, so these 2 I here. This will be the 4th element, 5 element, 6 element of the list. So basically this will be like this. This will be the x coordinate. So we make a small x. This will be the y coordinate. This will be the color red, green, and blue. Now let's say that I want to set the cell at 3 and 2. Let's actually attach a new jit cell block here, so we can also see. Let's actually copy also this stuff, the coordinates here. Let's actually put it here. So let's actually set all the coordinates. So it will be 5x, 6x, 7x, 8x, 9x, so 10 cells. 9 plus 0 is 10 cells. So this will be 0 for the y, 1 for the y. So let's say now that we want to set the cell on 3x to y. So this will be the x coordinates. And those will be the y coordinates. So let's say that we want now to set the cell at 3x to y. So what do? Is we write 3 here and 2 on the y, and then we write the maximum amount of red on the red channel, and then we send a bang to the pack object. So it will send now the list. We can also visualize this list. Set cell 3 to 255, 0, 0. And now we need to send a bang to jit.matrix in order to visualize this matrix on the GPU window. So as you can see, the cell that is at position 3 and 2 just got red on the first plane. The other two planes remained set at 0. So let's take a look actually with the plane message at the other planes. So plane 0 will be 255, plane 1 will be still 0, and plane 2 will be still 0. Okay. So let's say now that we want to set the green channel of the first cell, so the cell at 0, 0 to the maximum amount of green. So let's set at 0 here, 255 here. Let's set at 0 here, at 0 here. Let's set a bang, so the list will go out, and let's send a bang to the matrix to display the matrix on the GPU window. As you can see on the plane 1, the first cell became green. Let's now set another cell to the blue value. So let's actually set the cell that is at 1, for example. So let's write 1 here, send a bang here, and we have this cell got just got blue. So it's clear how the cell coordinates work. Basically, every cell has its own coordinate, and they start to be indexed from 0. So every cell or pixel, when talking about images, will have its own coordinates. And we can also set those pixels directly, individually, using the set cell 2D message and a jit matrix. Now, this is cell set 2D, so 2 dimensions, only because this matrix has 2 dimensions. If we would have done this with a one-dimensional matrix, so a matrix that has just one dimension here, in this case we would have said let's set cell 1D, and this would have had one coordinate less. But for the moment, let's use a matrix that has 2 dimensions, so a 2-dimensional matrix. Okay, so let's now copy this. Let's put it down. And let's create a little algorithm that will automatically fill a matrix with random numbers, with random values. So let's make this bigger. Okay, so we can do it by providing some coordinates to the set cell to the message and some random values for the colors. So we can do this by using, for example, the random object for the coordinates. Now, the coordinates go from 0 to 9 on every axis, x and y. So we want a random 10, because this will give us numbers between 0 and 9. So let's create a couple of those. Let's create the metro object with an interval of 200 milliseconds. Let's create a trigger, bang, bang. So we will first bang this random here, and then we bang this random here. So this will be the y coordinates, and this will be the x coordinates. Let's create a toggle to activate the metro also. And let's attach this here, let's attach this here, but let's also create some random for the colors. So let's create other 3 random messages from that will go from 0 to 255. So we write inside 256. So let's create 3 more bangs. So first this, then this, then this. So this will be red, green, and blue. And we can attach this to these integer boxes here. So actually put those here. Okay, and now we need another bang to actually trigger this list out. So this should be the last bang that we send So let's create another bang here, and let's move all these cables on the right, one spot on the right. So we can connect this bang here. And then we need also to trigger the matrix. So let's actually create another trigger here. Let's delete this, where we trigger the list, and then we trigger a bang to send out the matrix. So let's start and see what we get. So you can see that we are filling this matrix with some random colors, as you can see. And this is our first kind of procedural image creation. So very simple, but already kind of generative image creation. Now, if we want to have more pixels, we can create a bigger matrix. So for example, 100 by 100, and then we just have to set the same number here in the random object for the coordinates. And then we can see that we fill the entire matrix with some random numbers. Okay, so this will be it for this tutorial, and in the next one we will see how we can generate some more images procedurally with jit.matrix and some little algorithms and some little random coordinates and stuff like that. And as always, if you want, you can support me on my Patreon. I will leave the link in the description, where you can find a lot of other patches and lessons and stuff on how to create visuals with Max. So thank you for following. See you in the next tutorial. Ciao everybody.